today. Please let us know where you're joining from and introduce yourself. That way we can keep the interaction going on the chat. Uh, I myself, Rajesh, I lead the integration practice at Aviva. I'm based out of SF. Today we have Rohan and Simon who will be talking us through the async API end-to-end support. I'm pretty excited about this because everybody loves real-time data changes. So I'm excited to hear what we have in store on today's session. Um, Rohan, you want to introduce yourself and then we can get started from there.
Yeah, 100%. Hey everyone, my name is Rohan. I am on the product marketing team here at MuleSoft. Yeah, super excited to chat about Async API and all the new stuff we have just released. I'll let Simone do a quick intro too, although so many people know Simone, so
Yeah.
I don't know if you need to. But Simone, aka the Secret Ninja, take it away.
Yeah.
Rohan. Today I'm not the secret ninja. I'm here in front of the camera. For those of you who don't know me, my name is Simone Geib. I'm Director of Product Management at MuleSoft, and I lead product management for Anypoint Code Builder API Kit, and I am the technical lead for these new EDA features that we're talking about today.
Awesome. Thank you. Just before we start, please use Q&A to log all your questions, and we will be moderating the questions as it comes through. Yep. Over to you, Rohan.
All right, cool. All right, let's dive into it. Quick agenda for today. We'll just high level talk about what is EDA. We'll start talking about asynchronous communication and why we are releasing support for it and what the advantage of it is. And then we'll talk about what we're actually releasing. We'll go through EDA and the platform and how we're supporting it across design, governance, discoverability, and implementation. We'll do a quick little demo, and we'll end with addressing some of the Q&A from everyone that's attending. And yeah, that should wrap it up. All right, so high level, what is EDA? Kind of thinking about it, EDA is a way to structure applications to process events. Typically involves kind of three core systems here: a producer, a consumer, and a message broker. So we can see on the left-hand side here, we have all of our producers. On the right-hand side, we have all of our consumers. And in the middle, we have some sort of event broker or message queue. So the middle part here is the key kind of piece of this whole architecture. And it actually allows the distribution of events from the producer to the consumer. Couple benefits, big benefits here. One, you're able to achieve more real-time communication across these systems. And then second, you are able to add a layer of resiliency because you have separation from the producer and the consumer. In case something goes down, in case there's too many things or events happening at the same time, the broker sits in the middle and is actually able to handle all of that for you. So the real-time aspect of this and the resiliency are kind of the big advantages as you look into adding kind of event-driven into your architectures. So when we think about event-driven, one of the big kind of communication methods over the last 10 plus years has been synchronous communication. And we've seen this kind of become very prevalent in most architectural styles, but unfortunately things like synchronous or RESTful applications aren't ideal for all circumstances, especially not with kind of like the rise of IoT, smart devices, all these different things. It wasn't initially built for that in mind. So when we think about your architecture and your tech stack, relying solely on REST APIs isn't ideal. You want to have ideally a mix of a couple different communication technologies. There's a couple reasons REST isn't great for events. So the first one is polling. 98.5% of API polls don't return any new information. Right? You're sitting there asking over and over again for something to update, and then it updates maybe every 5 minutes. It's a lot of wasted time just kind of asking for information. In addition, kind of the setup for REST, or synchronous communication, is excessively coupled. When you have two applications that are, or multiple applications that are all kind of tied together, point to point, you can run into the issue of, when you want to make edits, you want to make changes, it can get difficult. And kind of the lack of real-time aspect to this, in the sense of, again, kind of going back to the polling, your response times can be low as throughput gets high. When there's a lot of requests coming in, you can see some delays. So when you're not looking at synchronous communication, how do people actually integrate with things like event brokers? And there's a few ways you would do this. If you do purchase an event broker, some of the very popular ones: Kafka, Solace. We have our own message queue at MuleSoft, which is called Anypoint MQ, and things like Salesforce Platform Events, and there's countless other ones, RabbitMQ, and a whole slew of different brokers and message queues. How do you actually bring these things into your existing architectures? A lot of the times, the brokers will offer connectors, out-of-the-box connectors that you can use. So things like, public clouds, private clouds, or public clouds, and SaaS applications like Salesforce can be pretty easy to start integrating with, at least that initial integration. But oftentimes, you'll still need to build a lot of custom, business logic, logging, message validation. All this stuff has to be built around it. So it's not really plug and play as you would like. In addition, when you start using these kind of out-of-the-box connectors that are offered by these brokers, you're really not encouraging a scalable integration strategy, right? So you're building point-to-point, and it's not really ideal for a scalable enterprise. So what can you do? And this is where asynchronous communication comes into play. Asynchronous APIs are specifically built to communicate with events. And so unlike synchronous APIs that require a call to be completed before the next one begins, using an asynchronous API allows the client to actually start executing other tasks while waiting for the server to respond. So it's able to essentially handle these high throughput scenarios. It doesn't need to make that validation of the message being received. And essentially is able to optimize for the processing of events. And on the platform, we are releasing the capabilities for AsyncAPI. And in addition to that, we are also helping you conform with the AsyncAPI standard. So similar to OAS or RAML or any of the other REST standards, there is a standard for AsyncAPI as well, which is called AsyncAPI. A little confusing with the standard's name, but this is the open source standard for asynchronous communication, and essentially allows you to scale your creation of async APIs, again, by conforming. I think generally it's best practice to have some sort of standard that you're using. And again, this promotes multiple benefits across the organization, collaboration between developers in the form of consistent documentation. You have reuse as you want to extend this out to other applications. Governance, again, making sure everyone's building in the same way. And then productivity, right? When everyone has that single kind of standard to conform to, it just helps minimize the amount of kind of useless or potentially inefficient code that's being written. So really, by adopting async APIs and using that standard, we're able to easily communicate with these event brokers in a scalable manner. So with that being said, what are we releasing on the platform? We are releasing end-to-end event-driven integration support on Anypoint platform. This is going to allow you to do a couple of things. So one, you're going to really easily be able to create real-time architectures and extend them out from your existing architectures. So we're building a way to seamlessly bring this into Anypoint platform. Traditionally, we're trying to build a unified platform to handle all of your integration needs, right? So including REST, GraphQL, and now async as well. In addition, we're making it really easy to conform to that standard. The AsyncAPI standard is like the gold standard as you build out your asynchronous APIs, and you're making it really easy to conform to that standard so that you're able to promote that kind of concept of scalability. And with the addition of this cataloging into Anypoint Exchange, we're going to make it really easy for everyone to get a hold of this, right? After you build or design your AsyncAPI specification, you can essentially make that available to all of the developers or different teams at your organization and have them use it and take advantage of it and kind of bring access to event-driven. So to take a little closer look at this, I'm going to pass it off to Simone, and she's going to take us through kind of the journey of the different pieces that we've released.
Thank you, Rohan. So this slide is a really good representation of the journey of a customer through an EDA architecture. Customers that want to embark on such a journey, they need to invest in adapting their enterprise to support evented applications, of course. If they're interested in an event broker or message queue, such as Kafka or Anypoint MQ, it's just the first part of that journey. They also need to integrate that evented system into their application network. And this is where MuleSoft comes in to help. We are providing them with a single platform for end-to-end event-driven integration. And if you look at this slide, with the new capabilities, customers can design AsyncAPI specifications using Design Center, with Anypoint Code Builder following soon. Current plan is October for that. And API Designer has been updated with the ability to author AsyncAPI 2.6 specifications. Then they can govern their AsyncAPIs. So with this new capability, they can now make sure that their AsyncAPIs conform with the AsyncAPI standard and also best practices through governance at design time. The next is discover and reuse. So they can discover and reuse their APIs and events across the organization by publishing the AsyncAPI specification to Anypoint Exchange for other teams to use within their own projects. And then the implementation of those evented applications using the new API kit for AsyncAPI module. This module accelerates the implementation process by handling the scaffolding, the message validation, and providing data sends for incoming and outgoing messages. And this will all become a lot clearer as we walk through the journey. The first step in the journey is to leverage a standard to define the event-driven or evented APIs. Traditionally, events did not have a single standard like REST APIs, but as you know, having a standard was fundamental to the success of REST APIs. Now, in case of events, if you have not heard of it, there is a specification called AsyncAPI. It's very similar to OAS, but it's very, very specific in its structure for event-driven APIs. At its core, it's an API specification just like anything else. And using this specification, developers across the world can speak a consistent language on what their event-driven service does. It helps address many of the challenges that Rohan talked about before. For instance, the ability to auto-generate dynamic documentation for others to read. Using the AsyncAPI specification, it gives you a common way to talk about your event-driven architectures and to define what exactly is happening there. And AsyncAPI specification is open source. It has support from many industry leaders. So everybody can contribute, everybody can improve the specification to suit everyone's needs. And with that, now it's getting really interesting, and let's walk through the end-to-end journey with our API and integration developers. So we are starting with the API developer who is going to Design Center within the Anypoint platform, and he clicks to create a new API project. He selects the option for new AsyncAPI from the menu. It's worth mentioning that the API developer also had the option of importing from an existing file or synchronizing from an existing GitHub repository, or to use an existing example in Anypoint Exchange. But in this case, he's starting with a blank slate. He then gives the new API specification the name of order service. Probably should have mentioned the end-to-end use case that we are talking about here is an order service. And now he also notices that there are two new options here available to him when creating his new async API. We now have async API 2.6 in YAML and also in JSON in the struct down. He chooses the YAML format and he clicks OK to proceed with creating his async API spec. So we fast forwarded a little bit here and added all the details to this async API spec. But let's have a look at the different parts of this. So first, this specification defines the details of the message brokers in the server section. So this is the first big difference to a REST API. So with evented APIs, you can define the different message brokers that you are using in your implementation. In this case, we have Kafka and MQTT in this async API. And if you remember what Rohan mentioned before, in our first implementation of this, we are supporting Kafka and Anypoint MQ. So you will see when we get to the implementation that we are taking the Kafka server type here, but for now, we're not doing anything with MQTT. So underneath the server section, then there are the channels. The channels describe basically what you do with your events. They describe operations like publish and subscribe. They define the message formats and the message type in that section. And just one thing I'm telling everyone when I talk about async API, there is a quirk in the async API specification. When you define your API, you have those publish and subscribe operations. But when you then translate that into the implementation, what is defined here as publish is basically translated into a listener. And what is here as subscribe is translated into a publish. It's just how the spec was written. And in the Async API 3.0 specification, they basically changed that so it will become less confusing. All right, let's move on to the next step. So before publishing this API specification, the API developer wants to make sure that the API is compliant and follows best practices based on what we have defined as async API best practices. So for that, he then goes ahead and he applies the async API best practices rule set. Let's move on to the next slide, Rohan. So you can see here from API Designer, you can find the rule sets in API governance, and there is one predefined rule set for async API 2.6 best practices. So once these have been applied to the API, you will see if there are any errors or any warnings based on the API specification. And so now the API developer can go through and you can see here like all the yellow underlinings, those are all warnings, which means that the developer does not have to heed those warnings, but it is a recommendation if they want to follow best practices. So he goes through, he checks all the warnings, he makes all the changes that are necessary for this API to conform. And then in the next step, he can now publish the API spec to Exchange. So this will make the API discoverable for others, and it will also provide the ability to implement it. So let's move on to the next slide. In there, the API developer says publish to Exchange. He gets a number of settings here. In this case, we're going to publish the API as a stable API because it is now ready for others to review and use it. And he goes ahead and publishes the API to Exchange. Now he can go ahead and review the async API specification here in Exchange. He notices that the API documentation is available conveniently alongside the API spec in Exchange, just like it was an API designer before, and he performs a final review before he says this API specification is now ready. So let's just recap real quick. The products that I have talked about so far are API Designer and API Design Center, API Governance, Anypoint Exchange, and also the API Console. All of those products have been updated to support AsyncAPI 2.6, and they are generally available as of this week. What we're going to talk about now is the ability to implement this previously created async API specification in Anypoint Code Builder and Anypoint Studio. This capability is open beta as of Monday this week. And the ability to implement this API is powered by the new API kit for async API, scaffolder, and module. I know this is a mouthful, but this is basically very similar to the API kit for REST and the other API kit modules that we already have in our Anypoint platform. Without this, developers had to do a lot of manual work for implementing EDA applications, which obviously adds time and complexity to their projects. But the new API kit for async API scaffolder drastically simplifies this process, making it as easy to work with async API as it is today to work with REST APIs on the Anypoint platform. And again, in the current open beta, we are supporting building event-driven applications for Kafka and Anypoint MQ. And we plan to extend support to Solus PubSub Plus and Salesforce Platform events in our October release. So now let's continue with our integration developer. The API developer is done with his work. The integration developer comes in, he opens Anypoint Code Builder, and he chooses to create a new project to implement an API specification. He gives it the name order service because he wants to implement the API that was previously designed. It's worth mentioning here that any async API can also be added into an existing project. And it can also be updated. So if you did an initial implementation of an API and then you go back and maybe you add another message broker or you add operations or new message types, then you can go ahead and take your existing project and you can update that. And that is called rescaffolding and also exists in REST today. But in this case, the integration developer is searching for the async API specification that the API developer has previously published to Anypoint Exchange. After locating the order service async API in the results list, he can now add the asset to the project. And you can see here that we have added this new filter in the API type, where he can just filter out async APIs and he can then search for all of the async APIs in this project. But in this case, he's going to use the order service. And then in the next step, everything looks okay. He gave his project the name, the location, and he's now going to click Create Project to process with creating his project. And then what happens in the background is obviously a new project is created on the disk and the scaffolder kicks in, introspects the async API specification, and then scaffolds the flows into the new project according to what has been defined in the API specification before. And you can see here now we have our new project and we have one unique flow created for each of the publish operations defined in the API spec for the Kafka message broker. Again, we are for now ignoring MQTT because it is not yet being supported. And also a reminder again for you that the publish operations in the API spec have been translated into a listener here. So you can see in this flow, you have the listener, listening for the event defined in the specification. And we also put in a logger here for easy testing. So in the next step, the integration developer checks all the flows that have been generated based on the API specification. In this case, we have 4 flows, all with listeners and loggers set up. And now he goes through, he adds his business logic, just like he would do for any other application. In this case, we are checking inventory after we receive the order based on if it is in stock. We then go ahead and create the order. If it's not in stock, we notify the customer. So he adds all this business logic, and you can now test and debug this in Anypoint Code Builder, just like with any other application. And then when the application is done, is working, then he can go ahead and deploy it to Cloud Hub using the Rocket item there on top. So this was a quick walkthrough on how this works. And this is another summary of what is available today. But just real quick, how can you and how can customers get access to this? So as I mentioned, the design, governance, and cataloging of AsyncAPI 2.6 specifications is generally available in your Anypoint platform. So you can go ahead and use that as you can any other product. And we also released the open beta for the implementation in ACB and Studio. So there is an additional step needed before you can actually use those features. And this is for the Anypoint organization admin to go and accept the terms and conditions of the open beta. You will see when you go into ACB and when you go in Studio, there is now, when you want to implement an API, there is a line which says, well, your org admin first has to accept the TNCs. There's a Learn More button, which gets you to the page where the TNCs can be accepted. And after that has been done, you will be able to search for async APIs. You will be able to implement them in your projects here. And then, as I mentioned, in October, we are ending the open beta. We will make the implementation of evented applications generally available in ACB and in Studio. We will add the ability to design async APIs in ACB itself. And we are extending the support of our message brokers to Solus PubSub Plus and Salesforce platform events. And between those 4, Kafka, Solus, Anypoint MQ, and Salesforce platform events, we believe that we will support a vast majority of our customers' core use cases. We did a lot of surveys and prioritizing of the message brokers, and those 4 are the ones that have been mentioned the most that customers are requiring to get started with this. Then in February of next year, we are planning to bring in updates to support the AsyncAPI 3.0 standard. And obviously, we will also, based on feedback from our beta, bring in enhancements or new capabilities. And we are also planning of supporting 2 more message brokers in February, but this will all depend on the feedback from the beta. This will then support our short-term vision of providing end-to-end integration support for event-driven applications. And of course, there is much more coming in the future as well. So please stay tuned and please do give us feedback. It's very, very important that you and your customers are providing the feedback during the open beta so that we can prioritize future capabilities accordingly. And with that, I've talked a lot. Let's move on to a quick demo that then visualizes what we have done for this feature. So the demo will go basically through the same steps that I have talked about. So it will design an async API for a real-time order processing application, including applying the governance rules. Then it will scaffold the API in ACB and build out the application logic, and then run the application and validate the results and deploy to Cloud Hub.
Adoption of event-driven architecture is accelerating, especially for use cases and scenarios that require low latency and high resilience. Adopting async API standard makes EDA initiatives collaborative, governable, and enhance developer productivity. For this demo, we will use a very simple order processing scenario and leverage two popular event brokers, Kafka and Anypoint MQ. The first step in an API-led approach is the design of an API. API Designer now supports Async API 2.6. To begin, we simply provide basic details such as name, version number, and the choice of YAML versus JSON as the language. Our new async API specification first defines our Anypoint MQ and Kafka servers, followed by 4 channels, one each for orders placed, cancelled, confirmed, and backordered. Each of these channels consist of both publish and subscribe operations. We will use Kafka for backorder workflow and MQ for the rest. Let us run some governance rule sets on Async API to ensure that it is compliant with best practices as well as company policies by importing the Async API best practice rule set. I'm able to address the deviation that was found rather quickly. Once I'm done with all my validation checks, I am ready to publish my API to Anypoint Exchange. I can now implement this async API specification. In my IDE to implement this, I search for it first and then give my new project a name. In the IDE, I find 4 scaffolded flows, one for each of the 4 channels. Let us first work on the order placed flow, which checks incoming orders against inventory and triggers either confirmed or backordered flows by publishing to the respective channels. With a few simple clicks, I configure the channel within Anypoint MQ that my publish operation will write to and trigger order confirmation communication. As you can see, with this approach, we have abstracted away a lot of heavy lifting that would have otherwise required deep knowledge of the respective broker or queue. All right, we just finished building out our entire async application. Essentially, when enough inventory is available, we will confirm the order, else we will backorder it. In either case, we will inform the customer via both email and Slack. Let us now test our application logic using an order quantity of 12 that is less than the inventory we have, which will trigger the order confirmation pathway. To do that, I'm here in Anypoint MQ portal to push a JSON payload across. We do see order confirmation messages come through in real time, and that's exactly what we were expecting here in email. And of course, the Slack message should also be here anytime. And there it is. Thank you.
All right, so I have been answering questions on chat, but
Yeah.
Rajesh, I don't seem to be able to reply on Q&A. Maybe I don't have that permission. I'm not sure.
Yeah, I can ask those questions and we can respond.
Yeah, we can do that verbally. I think we still have time.
Yes. So we have first question from Ivan. Could you please tell the difference between projects using queues without specifying async API and projects with implements async API? Basically, they are two doing the same thing using queues as event propagation, but async API defines the message structure and queue interface.
Yeah, so that's a really good question. It is correct that today you can already implement event-driven architectures in the Anypoint platform. You can use the Kafka connector or the Anypoint MQ connector, and you can set up everything yourself. What you get by using this mechanism is, first of all, you can define everything in an API specification in the same way as you can do in REST. So if somebody if somebody has experience with async APIs, it's a lot easier to define like the message brokers, the messages themselves, and everything in the API spec. Plus, some of the message brokers, like Solace, for example, have the ability to auto-generate those specifications based on what you have defined in your message broker. So you have defined your queues, you have defined everything in there, and then the specification is auto-generated. So that is one thing. And then the other thing is the API kit. First of all, it has two, if you know the API kit for REST, you know this already, but it basically has two functions. So first is the scaffolding. So you introspect the spec and then you create all those flows, but it also is there at runtime. So at runtime, what it basically does, it does the routing of the events to the right flow. And let's say you define in your API spec, you have Kafka, you have Anypoint MQ, and you have queues that are dealing with the same messages, but they may be doing like slightly different things. You will only need one flow for all of the different message types and all of the different brokers if they are using the same operation. So you're listening to new orders, but you're listening to different queues, then you only need one flow versus two flows. Also, API Kit makes sure that the messages coming in are valid. So even before they come into your flow, the validation is checked. And when a message is published, again, the validation is also checked. So you don't need to, if you do this manually, you have to put in a node for validation, and then you have to have a condition afterwards, and you have to do that all manually. And third, we are providing data sense through API Kit. So if the message format is defined in the API specification, then we are providing the data sense in your flow so that you can easily transform the message or extract values from the message. Like for an order message, for example, you have an order ID, you have the items, you have the price and everything. And in the flow, you will then easily know how you can extract those values or how you can transform those values, because we already give you the data sense. If you do this just with the connector, you're basically blind on what your message structure looks like. So I know this was like a long answer, but I hope that that answered your question.
Thanks, Iman. Moving on, we have a question from Maxim Kogan. As far as message listener consumer element in Kafka case, will it support all the Kafka bindings? AsyncAPI.com, there's a link with the Kafka bindings and apply bindings configured. Are there additional similar consumption configuration options in the UI?
So for the first question, we are supporting all the bindings if the connector supports them. So important to know that under the covers, we're still using the Kafka connector. We're still using the Anypoint MQ connector. So we are, I don't want to say limited because that sounds negative, but we are able to use all the configurations that those connectors provide to us. And obviously, when we implemented the scaffolder, we worked through the Kafka bindings, through the Anypoint MQ bindings, and translated them into the configurations of the connectors. But I'm not completely sure about the second part. Are there additional similar consumption configuration options in the UI? So basically what you get in the config panel for the Async API, API kit for Async API is that in there you can then select the channels and you can select the servers. So we do use exactly what is configured in the API. There are some things that you can change. You can change the URL, for example, for Anypoint MQ afterwards, and obviously the credentials, but you cannot, for example, change the queue name or the topic name based on what was defined in the API spec. If you want to do that, then you go back to the spec and then you rescaffold it, and then the change will be made in the application, if that was your question.
Okay, thanks, Simon. The next one is from Mohammed Altrash. In one of my previous use cases, I used to read events from Salesforce and then publish them to MQ. another component where listening to the queue and then process the event. Do I need to change this mechanism to async API and why?
So you don't have to change that. I mean, this is still a valid use case. So we are not taking away what already exists today, but based on what I explained previously, maybe for your new projects, if you want to try out specifying the API and then implement it that way, and then take advantage of what API Kit gives you. Again, it's the validation, it's the routing, it's the data sense. Then I would recommend looking into that and trying that out.
Yeah. Uh, so we have one question from Ryan. Hayek, is there visibility into async API roadmap? Is it available on ideas.salesforce.com? I'm very interested in client connectors like REST and in async API gateway and support in API manager.
So I think the connectors you're talking about, Ryan, is the REST Connect like. I answered that question on the chat before. So I don't know if there's a way for us to make this roadmap public, but really what's very, very important for everybody to understand is there's a reason why we're in open beta right now. We have a roadmap in mind, but we want to get feedback. We want you to try this out. We want you to tell us, well, it's great that you have those 4 message brokers in mind right now, but I really want to see XYZ message brokers instead. And yes, this is great, but I want to see this in Experience Hub or an API Manager or such. So that's why the roadmap that we have shown you in this deck is what is planned right now. But based on the feedback, obviously October, it's too late to make changes to that. But for February and later, the roadmap will be adapted based on the feedback that we will receive. And I don't know if you want to add anything to that, Rohan.
The only thing I wanted to add was the feedback link is right there on the screen.
Yes,
So
good point.
if you do want to have feedback, I think I saw some that actually came in through the chat already. Go to the link and put it there so we can document it and we can show it to people and say, look, this is what people want. It helps. So please do.
Thanks, Rohan. Thanks, Simon. We have next from Steve Son. In REST APIs, when API Kit detects invalid data, it rejects the message and notifies the sender via 400 error. In the async world, does the sender publisher receive a similar error to know that the message has failed to publish?
Yeah, so that's a very interesting question. Obviously, asynchronous communication is asynchronous. So there are no replies like in REST, but what does happen, for example, in Anypoint MQ, which is what I have mostly used for testing, you can define in your settings, first of all, a dead letter queue. You can also define redelivery limits and such. And so if the message is rejected, it will not be acknowledged to the queue. And so you will know based on that behavior. So this is where queuing mechanisms are different from synchronous and REST. So the message is not taken off the queue and is not acknowledged if it is not valid. So hoping that answers that question.
Yeah. So I'm just going to the chat to see if you have any questions unanswered there. So we have one request from Anil Kumar. It will be good to have some example use cases in Exchange, for example, SF events and Anypoint MQ, etc. I would say, Anil, if you could, if you are already subscribed to Twitch channel, Alex does a lot of sessions and workshops there, so I'm sure this will be in her to-do list as well. Right, Ron?
Yeah, so I know we also got a request from somebody else about providing examples in Exchange. So I need to look into who is actually responsible for doing that. We have some examples and we will work on making them available publicly in Anypoint Exchange.
Sure.
just to add on to that, Raj mentioned Twitch. We did already do an AsyncAPI Twitch stream on Tuesday, so that's up. I'm putting it in the chat, or at the Q&A. What am I doing? In the chat. I'll put it in the chat right now. Check that out. It is a deep dive into kind of the step-by-step process to actually do this with one of our SEs, John. So take a look at that if you do want some immediate content. And there's going to be more stuff coming down the pipeline in the coming weeks to help people start getting onboarded onto this and learn the ropes. But yeah, do a quick plug for Twitch. Check that out.
Good point. And I see a question from Mohammed. So instead of like a technical explanation why you do that, what's the business explanation? And I think business is all about saving money. So this will make it easier to build event-driven architectures. It will also make it more efficient. And without going into too much technical detail, it will also save the number of flows that you need to use for your event-driven architecture, which in return, given the new usage-based pricing, which includes the number of flows, will also save money. So it's all about making it more efficient, making it more cost efficient, making it faster and easier to do, which in turn also makes it more cost efficient and makes it more reliable as well. Because we have like also the message validation and all of that. So it just makes the whole architecture more reliable and make sure that it works properly. So maybe that's more what the business wants to hear. And Rohan, I know you want to add something as well.
I was just going to add scalable in the sense of defining that API spec and then having people that, maybe aren't 100% familiar with the broker and don't want to go through the whole struggle of setting that up manually. They have someone that goes in, builds out that spec, and they can just use that rather than doing it all themselves from scratch. So I see that as another big plus point into why you would want to build that async API spec and make that available to everyone.
Yeah, and there's also, I think there's a better separation of responsibilities if you do it this way, because when you implement an event-driven architecture, you have to understand how the message broker works, what are the messages, what's the structure and all of that. But if you can now separate those concerns into the person who understands all the setup and the person who understands how to implement a new flow, that will also make it more efficient.
Yep. Moving on, we have one question from Larry Mayers. How did you say we access the open beta?
Okay, so just go to Studio, or make sure you install the latest version of Studio, obviously 7.18, or the latest version of Anypoint Code Builder. And then if you go to implement an API, you will see that AsyncAPI needs enablement by your org admin. There's a learn more link that gets you to anypoint.mulesoft.com/anypointcodebuilder. I think that's the URL, but it links you directly there. And on there, you will see a new banner which says you need to accept the TNCs if you're an org admin, join beta, and then it opens the TNCs. You can go through them, accept them, and you're all set.
Awesome.
Thank you, Ryan. Looking forward to your feedback.
Yes, thanks, Ryan. So I think with this, we have pretty much completed all the Q&As. Let me check one last time. Okay, there's one. Any thoughts about Kafka schema registry support?
Kafka. Oh, yeah, I know. So we have been looking into that, and we are still trying to understand how exactly we can bring in that support into the Anypoint platform. So stay tuned. We hopefully will have an update in the near future about that. But
Awesome.
one more thing that I do believe Maxime may be interested in. So this current release does not yet support Avro, but that is also coming in October. So we will have the ability to define an Avro schema in API Designer, and or actually we are going to do that in Anypoint Code Builder, I believe, and then publish that to Exchange. And then it will also be used in the implementation. So if you use Kafka, then you will be able to use those Afro schemas, and it will be part of the whole implementation. We have enhanced data sense to deal with Afro schemas as well. So that is all coming in October. All
Okay.
right.
Um, yeah, I think we have covered pretty much all the questions. Yeah. So thank you everybody. Thanks for joining. This has been a great session. A lot of questions and very interactive. Uh, any final comments, Rohan, Simone?
Just call to action. Use it, tell your customers about it, tell the world about it, and give us feedback.
+1, yeah. Do what Simone said. um, yeah, I think we'd love to get your feedback on this. Test it out, try it out. Go to that URL and let us know how your experience was, and what you want to see next. Just echoing what Simone said earlier. Um, it's a huge influence having you guys come in and say, hey, like, I want to see X, Y, Z. Again, we can take all that information, we can compile it and bring it back to our leadership team and make sure they prioritize it. So if there's stuff you want to see, test it out, use it, give us feedback, and we'll do our best to make sure that gets worked in.
Thanks, Rohan. So thanks everyone for joining. So I will publish this recording on our YouTube channel, and so you should be able to view this session and also the slides there. With that, thanks everyone for joining. Have a wonderful day ahead.
Thank you, everyone, and thanks for hosting, Rajesh.
Thanks, Simon. Thanks, Rohan.
All right. See you later.
See
Bye.
you. Bye.